everybody. Today we're going to continue to take a look at finding the area of rectangles. And you'll notice that today I have some squares sort of set up here because we're going to talk about a few important things. So first of all, let's just take a look at the tiles that I have here. You'll notice that I have two different size tiles here. And even though this isn't exactly accurate, I'm going to label these as inch tiles here, okay? Which means that each side of our tile is considered to be 1 inch long. So this is a 1 inch square tile. Each side, let me undo that for a quick second. Each side is 1 inch long. So this side is 1 inch, this side is 1 inch, this side is 1 inch, and this side is 1 inch to make a 1 inch square tile. Okay? And on the other one, these are going to be centimeter tiles. So same thing, except for they're a little smaller, right? Each side is 1 centimeter long to make 1 centimeter square tiles. Okay, you can think of the centimeter tiles like those base 10 blocks, those little cubes that we used for ones. Those are actual true centimeters. So you can think of the centimeter tiles as those. And if you're in class, I will be showing you what inch tiles look like. They're quite a bit larger. Okay, but the first thing I want you to think about is what I've got set up here. You can see that I've got some centimeter tiles and I've got some inch tiles, right? Whoops, I didn't want to erase the square. So the first thing I want you to think about is, if I'm trying to find the area of a rectangle, have I done that well with my tiles? Is there any problem with how I've set my tiles up, or are they good to go? So remember, last time we talked on Monday, we said that when we're doing the area of a rectangle, we want to make sure that there are no gaps and no overlaps. And I'm going to put that up here again. No gaps, no overlaps. Right? And on both of these, you can see that they have gaps, right? So it's not giving us a true sense of what the area of that rectangle is. So what I'd need to do, and this takes a little bit of time, is whoops, I don't want to resize them. I'll need to take each of my my square tiles, and I'm going to have to scooch them so that they are not overlapping. I don't want this. That doesn't work. But I also don't want the gaps. So we're going to line them up so that they're nice, but without resizing, so that they're nice and easy and not overlapped. See how that works? That looks a lot better, doesn't it? And I can do the same thing with my centimeter tiles, okay? So what I want you to think about as I do this is, what do you see that reminds you of something else that we've learned about this year? And I want you to think specifically to the beginning of the year with multiplication. We showed multiplication in lots of different ways, right? We've used equal groups, but we've used something else as well. Can you think about what that is? If you said an array, you are right. These look very much like arrays, don't they? And I'm going to write that here too. Arrays. It looks very much like the arrays that we were drawing back in the beginning of the year, and some of you are still drawing, right? Remember, I would say draw a 3 by 4 array, and you would do something like this. 3 rows of 4. Maybe you drew X's. Maybe you drew circles, right? Maybe you just did dots. Don't these look just like that, but with squares? That's pretty cool, isn't it? So finding the area of a rectangle is really basically the same thing as thinking of it like it's an array, because it really truly is an array. Okay? So the first thing I want you to think about is, I use the example of 3 times 4, a 3 by 4 array, because that's actually what we have here, right? I have 1, 2, 3 squares on the left side, and I have 1, 2, 3, 4 going across the top. Okay? So when I count all of my tiles, I can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total tiles. And what do we know about 3 times 4? If I have 3 rows of 4, that gives me 12 tiles. Do you see that? So I can count it by 4s, 4, 8, 12. I could count it by 3s, 3, 6, 9, 12. I could continue to count it by 1s if I wanted to, but that takes a long time. So we want to start to be efficient. So I would label this, this rectangle, whoops, as a 3 by 4, right? I have 3 going down on the left and 4 going down on the right. And I would write it as 3 times 4. A 3 by 4 equals 12 square inches, because in this case, it's square inches. These are bigger tiles, right? So the area of the rectangle I've shown is 12 square inches, and I've solved that by using multiplication rather than having to count. So let's take a look at my centimeter tiles. Well, on the left, look, I've got 3. On the top, I've got 4. So this is still a 3 by 4, isn't it? And once again, I can decide to count by 4s, 4, 8, 12. I could count by 3s, 3, 6, 9, 12. But either way, I'm going to come up with 12. In this case, it's not square inches though, because we're using a smaller unit. So we say that this is called square centimeters because we're using centimeter tiles. And notice something, even though they both have an area of 12, right? We came up with 12 as our answer. Do they fill the same amount of space? Look, if I color this whole thing blue versus coloring this whole thing green, do they fill the same space? They don't fill the same amount of space, do they? So even though they both came up with an area of 12, this is why our units are so important, because 12 square inches is a lot larger than square centimeters. And if I had you think about square feet, what would that mean? Well, that would mean each square has 1 foot per side. And 12 square feet would end up being a lot larger than 12 square inches or 12 square centimeters. If you think of square feet, think about the tiles on our classroom floor. Those are square feet. Every single one of those tiles is 1 foot long and 1 foot wide. And if you put 3 of those in a row, down the column, and 4 in each row, and looked at that 12 square feet, that'd be a lot larger than 12 square inches or 12 square centimeters. So this is why it's really important to have your units. So you want to remember your units, you want to make sure there's no gaps and overlaps, and you want to think about how many on each side so that you can be more efficient and use some multiplication to solve. Let's take a look at another one. Let's say I have a rectangle, but I don't have the tiles, right? But I can tell you how long each side is. So what if I told you this side was 2 inches and this side was 8 inches? Well, really all that means is that I'm going to take my side length on the left and I'm going to split it into 2 parts, 2 equal parts. See how that is? Here's my 1 and here's 1 and here's 2. This side is going to have to be split into 8 parts. So I'm going to split it into 8 parts. There's 2, there's 4, and I know these aren't very good squares, so I apologize. It's not very accurate, but it'll work for now. And you'll notice that I've split it up into 1, 2, 3, 4, 5, 6, 7, 8 parts. Now, I could again count all of those square inches separately, but I can be more efficient. I could go ahead and count by 2s, right? 2, 4, 6, 8, 10, 12, 14, 16. And we know if I take 2, the number of rows, times 8, the number in each row, 2 8s makes 16, or 8 2s. And in this case, we're talking about square inches because I labeled each side as 2 inches or 8 inches. So the inches is how long the sides are. The square inches is how many squares of those sizes would fit inside and cover the area of the rectangle. Does that make sense? I'll show you one more kind of like that. And if you need to on your assignment today, feel free to draw those lines in, okay? If you need to do that to be able to determine the area of a rectangle, you are welcome to do that. How about, what if I gave you something that looked like this? And I told you this side was 3 centimeters, and I told you this side was 5 centimeters, right? So if you're starting to get the hang of this, I don't like the way I wrote 5 centimeters. I'm going to redo it. If you're getting the hang of this, you may say, I don't need to draw those lines anymore. I know I can just do 3 times 5 to find the area inside. It's okay if you still need to draw them, so go ahead. I'm breaking this up into 3 equal parts. Now I'm going to break this one because it's 5 on that side, 3, 4, into 5 equal parts. Ooh, my squares came out a little better on that one, didn't it? And if I need to, I can count by ones, but I'd rather you be more efficient. I can count by 5s. 5, 10, 15. So therefore, I know the area of this rectangle is 15. But 15 what? 15 square centimeters, because there are 15 of these squares, and I've told you they're centimeter squares because I've labeled my lengths on the side as centimeters. Okay? So remember to include your unit because it makes a difference. Even though in my pictures my square inches and my square centimeters look similar, when you use real units that are not just drawn on paper, you'll see that there's a big difference between a square inch, a square centimeter, a square foot, a square mile. Okay? So units are important. Draw on those lines if you need to. Start relating it to a multiplication problem. And recognize that the side lengths are really just telling you how many tiles per side. Okay, so go ahead, try your activity. Good luck.